Hi, today's problem is the latest time to catch a bus. Um, Give me 5 minutes to read this problem and I'll try to solve it. Um, so basically the problem is about buses and passengers. I got the idea that the bus has a capacity and it arrives at moments of time defined as an input. Oh, there are many buses. So basically one stop, many buses and many passengers. And there is a queue of passengers that come of at moments of passenger yacht. So passenger yacht arrives at passenger yacht's time at array passengers. If they arrive early, they can hop in a bus before it departs, and if it's not full. If a capacity of fewer passengers are waiting for a bus, they will all get on a bus, or if the capacity of passengers is right, I will get on a bus. If the capacity of you so I'm currently interested if there are passengers that are waiting in a line and were not picked up by previous bus, if they gonna be picked up on the next bus or will just go away. I assume they will wait. So let's check this case. So we have buses arriving at moments 10 and 20 and with a capacity of 2, and the passenger number 0, it arrives at moment 2. Then we have then we have a bus arrives at moment 10. Then it takes the passenger number 0. 0 passengers are waiting. So the next one, bus arrives at time 20. So at time 20 we have passenger 17 that arrives at 17, and at 18, and at 19. So we have 3 passengers waiting there. And the bus can take maximum 2 that arrives at 20. And the output in this case is 16. So I wonder why we cannot go to there like 2. Why cannot go 3? Like it says something like earliest latest time you can hop on the bus. Return at the latest time you may arrive at the bus station to catch a bus. You cannot arrive at the same time as another passenger. Okay. And if it's not possible, should I return -1? So the constraints here. So the constraints here, the capacity is like 10 to the 5th, 10 to the 5th. Buses like passengers 10 to the 9th. So we possibly can get n log n time complexity. Each element bus is unique, each element of passenger is unique. Okay, let's check the second case. We have buses arriving 20, 30 and 10. I assume we should first sort it, and that will give us some benefit of like I assume the passengers also should be sorted because it's a moments of time they should arrive. And if we sort it, so it's already n log n complexity, and it might be next to the limit. Theoretically I can sort it in O of n, but yeah, I guess it's not bounding here with something like counting sort. I can reach O of n, but I guess n log n is fine here. The next question is how I should build a solution in a way that it selects the latest time to hop on the bus, so the latest time I should arrive to hop on the bus. So potentially I should start with the last bus and check if I can squeeze in, and there is also carryover, carryover of passengers. So what I wanna calculate is kind of let me cycle back. So we have 20, 30 and 10, and we have passengers like again the capacity is 2. So the if we sort it, we're gonna have 4, 11, 19, 13. It's all. Okay, let's copy this and let's go to Excalibur. Maybe I'll be able to understand it here. So we have the buses here arriving 10, 20 and 30. We have passengers This is buses, this is passengers ray. So it starts with 11, then 13, then, oh no, it starts with 4. 4, oh, 4, 11, 13, 4, 11, 13, 19, 21, 25, 26. So here the output, the capacity is again 2, the output is 20. So that's the latest time I should arrive to hop on the last or previous, or like whatever is possible bus, whatever is the latest bus. So if I go one by one, so incremental passengers like 4, like on the moment 4 we have 1 passenger, on the moment 11 including we have 2 passengers, on the moment 13 we have 3 passengers waiting in line, on the moment 19 we have 4 passengers waiting in the line. So at moment, and then we have, oh, sorry, that's not because, not exactly true. On the moment 4 we have 1 passenger in the line. At the moment 10 we have bus arriving, so we have 0 passengers in the line, so because it takes 1 passenger from the line. At the moment 11 we have 1 passenger in the line. At the moment 13 we have 2 passengers in the line. And then moment 19 we have 3 passengers in the line. Bus comes to at moment 20, so we have 1 passenger in line because bus takes 2 with it. The moment 20, so at moment 21 we'll have one passenger in the line. In the moment 25, 2 passengers in the line. In the moment 26 we have 3 passengers in the line. And then moment 30 bus arrives and takes like whatever 1 passenger left here, so it's like passenger this and this. So this bus takes like 2 passengers, and then 19 is left. So we cannot arrive later than 21 because there will be 20. The second passenger arrives at the moment 21. So to avoid that, you need to arrive earlier. Yeah, so somewhere we should squeeze in, and basically the moment when the bus arrives, we should arrive also too. So passenger should be there. Okay, so I think that I should somehow to maintain the counter and yeah, and ignore the the bus that arrives. So like just have the ends 4. We have here 1. On the moment 11 we have 1. At the moment 13 we have 2. On the moment 19 we have 3. On the moment 20 we have, oh no, on the moment 21 we have 1. On the moment 25. So here it's weird because I need to somehow build this mapping, and as of now I don't understand how to do that. So let me try again. So we have 4. So what I really want to do is to kind of start from there, from the right, and find a place where I can, that will be the rightmost place where I can squeeze in before the number of people gonna be equal capacity, where the number of people in a queue gonna be equal to capacity. So, but there are some exceptions, like this, when the bus arrives and there is no people arriving there, and it takes the people, and we change the queue, and if we change the queue, then so we do that again. So moment 4 we have 1 person in a line. On the moment of 10 it's a special, nobody arrives there, so we have 0 people in a line. It's change from 1 to 0. And on moment 11 we have 1 person in line. On the moment of 13 we have queue. On the moment 13 we have 2 people in a line. On the moment 19 we have 3 people in a line. On the moment of 20, so nobody arrives here, but the bus arrives there. So it changes from 3 people in a line to 1 person in a line. So in the moment of 21 we'll got 2 people in a line. 25 we have 3 people in a line. On the moment of 26 we have 4 people in a line. And the moment of 30, again, bus arrives, nobody arrives there. So we change from 4 to 2. So 2 people in a line at the moment 30. And basically, what I should do. So if I jump 1 by 1, starting from the right, to find the place where their queue will be less than capacity, and it's virtually any time, if it's possible. So I check 30, queue is less than capacity. no, Q is equal, Q size equal capacity. So I check 26. So potentially, like it was 4. It was 4, but 30, 31, it was 2. So potentially I can like do this proxy next cells, and whenever it's not occupied with the like arrival of the person, I can add their person if it's lower than capacity. So let me do that again. So we have 4, like we have 3, 4, 3 equals 0, Q line 4 equals 1, but it's arrival, Q size and moment of t. Then on moment of 10, moment of 9 we have 1, on moment of 10 we have 0, on moment of 11 we have 1, but it's arrived somebody, on moment of 13 we have 2, again arrived somebody, on the moment of 19 we have 3, but it's arrived somebody, on the moment of 20 we have 1, yeah, we have 1, and bus took over the rest of them. On the moment of 21 we have 2, but somebody arrived there. 25 we have 3, somebody arrived there. On the moment 26 we have 4, somebody arrived there. And on the moment of 29 we have 4, on the moment of 30 we have 2. So I wonder if I can like make it shorter, this array, by not introducing this previous cell. So in this case, if I have this, I need to go one by one and check if the Q size is less than capacity, and if the Q size is less capacity, and if it's not the moment when somebody arrived, I can just join there. Yeah, and it's important because like if I need to arrive here, I need to arrive like on the 24th. Yeah, so seems like this idea of having a temporary new cells. Let me check if I can like get rid of it and not have them at all. So yeah, it's hardly task that I thought. Okay, so let's do that again. So we have moment of 4 time. We have Q size 1. We have moment of 10, Q size 0. Okay, because it takes, let's assume it takes, so it's still a valid node when we can arrive, basically. Yeah, okay, so let's assume we have 11 1, we have 13, it's 2. We have 19, it's 4. We have what if I just don't include this? Let me experiment this way. I just don't include this arrival, but I will have in mind that basically when I calculate the queue size, queue size in the each moment when passenger arrives, I will account for this bus coming over and taking passengers there. So I have 19, so I have 20, one passenger left. I have moment of 21. So there are two passengers, not one passenger, but two passengers, if I write. So there are passengers 19, 4, 11, 20, 13, okay. 4, 11, okay, they are here. 4, 11, 13, 19, and then we have 21. So if we, on moment 19, we have 4 passengers, no, we have 3 passengers here. We have 3 passengers here, 18, 19, then 21, we have 2 passengers go by bus, 1 passenger left waiting in a line. On the moment of 21, we have 2. On the moment of 25, we have 3. On the moment of 26, we have 4. On the moment of 30, we have, oh, we don't include that one. We are indifferent, so let me count, so we have here -2, and here -2. So if I add all the passengers, it's gonna be 3, 4, 5, 6, 9, 11, 13, 16, 20. So there are total, what? No, wait a second, no. So there is 1 passenger, 2 passengers, 1 passenger, 1 passenger, 1 passenger, 2 passengers, 1 passenger, and 1. So there are, oh, that's not the passengers. So we have 1 plus 1 plus 1, 3, 4, 5, 6. 6 passengers. And here we have 1, 2, 3, 4, 5, 6, 7. So I missed 1 passenger. So we have 4, 11, 16, 19, 21, 25, 26. 7 passengers. So 1 passenger here also. Okay, yeah, sounds like correct. And now I need to go from the right, and I need to find whatever is the best, starting from 30, yeah, when there, or not even 30, like if we have here the only 1 passenger, yes, starting from the, probably from there, 30, it's the time when the bus arrives. Let's jump from the 30 times 30, we take the last in the line 4, number of passengers in the line 4. If we, so it's like 1, and then it will drop to 0, and then we have 1, have 2, we have 3, and then we have, so over here we have drop to 2, and then we have drop to 1, so here 3, 2, 1, here 1, we have drop to 1, and then we have, what we have increased to to 2 passengers, and then we have increased to 3 passengers, and we have increased to 4 passengers, and then in the end when it arrives we have drop by 2, so we have 2 in the end. So this is not really monotonic function, and what I'm looking into the moments when I can squeeze in and going from the right. So the moments I can squeeze in is the right if there is one left cell in here when nobody arrives. So I can go there if the capacity is 2, or I can go there, or I can go there, or I can go there, or there. If, and it seems like we have like drop right on the moment 20 and nobody arrives there. We have increased by 1 on moment 19 and 1 passenger arrives there, so it's not allowed to arrive there. So the only rightmost time where we can arrive is on moment 20. Yeah, I'm thinking right now how I can like make this, how I can make this how I can make it like solution and account for all the edge cases, because might be this gap might be like just 1 cell and I cannot put any passenger there because maybe some passenger arrived there, so I cannot go there, and I need to consider other options. Yeah. And again, this is pretty simple situation because there are just 2 capacity, but in case it would be like 4 or 5 capacity, it means that I need to go step by step, like when the capacity changes to 4 and when the queue changes to 4, and try to put it right before it if possible, when capacity changes to 3 and try to put when if it's possible, and when the capacity changes to 2 and do the same if possible. And there might be a situation when we have moment 21, 22, 23 and 24, and then capacity is like 1 and then 2 and then 3 and then here 24 and then 4, and it means that I cannot, and like here the bus arrives like at the moment 25 and I need to jump on this bus, and in order to like do that I need to go like 1 by 1, and the size is here like 1. Oh, it makes me think that it's an area problem. If if you have in this case, it's edge case, and the area of this thing is like 1 plus 2 plus 3 plus 4. It's gonna be 10, and this is the edge case versus if you have like something like this, means that nobody arrives there between 2 and 3, and the area gonna be just 5. Yeah, but still there is some kind of relation to the base, and if the base, and it's like always increasing, and then it goes down, and then again it increases, and it goes down, then again increases, and then goes down. And in this case, no, I'm only interested in, so it's like this, and it increases, goes down, increases, goes down, and then increases, and then it goes down, maybe on some non-zero level, depending on the capacity and the queue line size. And if you wanna like test the levels starting from the right, like this, and you wanna do that one by one, and if we fail to find the right place, then we will go to the next one and also try to do this, and then we try to go next one and also try to do this. And it seems like this function, like in the bounds of between the array, between the bus arrives and between the bus arrivals, this function is increasing here, and because this function is increasing, I can so there will be a moment of time when the capacity when the queue line will cross the capacity, and in this case I need to go check like -1 and check if somebody arrives there. If not, I will check, but if nobody arrived there, then here it's like somebody arrived there, so if the capacity is equal to the queue size, in this case I need to go left to find the moment when the capacity will be greater than Q, but again I need to do that kind of incrementally, because they might be not just -1, I can do -2. So the solution plan should be something like this, I assume. You'll have to build this graph first. It will be splitted into bus arrivals. The graph will be on the axis it's going to be time, x-axis, on the y-axis it's going to be queue size. And when the bus arrives, the queue size will go down, and yeah. So let's assume this one we have moment of time 4. We have +1. Then we have moment of time 10. It go down. One goes down. Then we have moment of time 11. It stays on 0, and then on 11 it goes up 1. On the moment of time 12, what? No, 13. In the moment of time 13, it goes to 2. In the moment of time 19, it goes, no, too much. In the moment of time 19, it goes to 3. In the moment of time 20, it goes down 20. And then on the moment of time, and not exactly to 0, it goes to just 20, and we'll use a white one. Time 20 we have it goes down to 1, to level 1, and then stays there. And at the moment of time 21, it goes to 2. So it was 1 here. 21, it goes to 2. And then 25, it goes to 3. To 3. And then in the moment of 26, it goes to 4. And then moment of 30, so it goes 4, 4, 4, 4. And then the moment of 30, it goes down to 2. And then stays on the level 2 forever. So, and we have bounds. We have bounds 10. We have bounds 20, the arrival of bus, and we have bounds 30, arrival of bus. Bus arrival, 2, 3, bus arrival 1. And my idea is to run the binary search for in between of every bus arrival, starting from 0, including 0, 0 here, and not including like the next bus arrival, and here we'll count from 0 from 10 to 20 not including, and then from 20 to 30 not including, and then from 30 on. And then I want to run some kind of binary search where I'm gonna try to find, so we have the capacity here, capacity versus Q line. If I run the binary search, capacity versus Q line, and I need to find the moment when the capacity would be equal to the Q line. Yeah. And in this case, the capacity to Q line equals to 13. Like if I do binary search like right here, and I need to basically find the, so I do 13 and I check the previous one, it's 11 and it was level 1, so I check, can I squeeze in to 13 before the 13, the previous one is 11, I check 12. Yeah, if I can squeeze in, I do that. If I cannot squeeze in, what I do, let's say here it's 12 instead of 11, I check the previous level one by one, and these checks can be quite interesting. So we have capacity here is passengers length. Passengers length can be passengers. So it can be quite tricky. So capacity can be passengers lengths, buses lengths. How I can find the length of the buses? And okay, so that's n. And then if I just iteratively go through the, like, let's say we have like this edge case where we have this increasing every moment of time, 0, moment of time 1, let's say 10, 11, 12, 13, 14, 15, so on and so forth, and we go one by one, and we try to find the place where we can arrive. Let's say this is 10 to the power of 5, and then here 10 plus 10 to the power of 5, and we try to, in this case, we try to find the place where where we can arrive, the latest time we can arrive, and we try and let's say assume capacity in this edge case is equal, let's say somewhere in the middle, so it's like somewhere here, like 10 to the power of 5 divided by 2, just. So in this case we'll use binary search, so it's going to be log 10 to the 5th to find this middle point capacity. Well, 10 to the power of 5 by 2. We use binary search. It's going to be log n, log number of buses or number of passengers, and then we're going to go one by one, trying the previous days as candidates for the earliest or the latest time to arrive, and we'll fail every time until we go to the level 0, and we'll say, okay, we can arrive here, and we can, let's say, it will be the latest possible time to hop on the bus, because all the next moments somebody else gonna arrive, and we won't be able to catch up with the bus. Okay. And if we cross to the land of the previous bus arrival, we'll just try again. Yeah, I'll try again to do the binary search of the capacity versus queue line, but starting from the previous start point, and we'll go and again do the binary search, and we'll find the moment of time when the capacity was equal to the queue line, and we try to do the -1 and check -1 to the -1 to the time when capacity became when the queue line became equal to the capacity. We'll try to do t-1, and we check if the previous arrival time for the passenger is equal to the t-1. If yes, we go to the previous one. If no, we found the latest time to arrive. Yeah, so that's it. Let me start coding that one. So the high level map for the solution. So we gonna first sort buses and passengers race its arrival times, race of t's, ascending. Second one, starting from right interval, when bus arrives, do this range. So let's assume that the bus arrives in the moment of t n. So we do and the previous bus arrives in the moment t n -1, and we do the binary search here in this range, and we try to find the moment of time t target when the queue line will be equal to capacity, and we try to do this t target -1 and check if the previous, and it will be like moment t moment t -1, and we compare it to the previous element when if anybody arrived in the moment t-1. If yes, then I do t-2 and t- until the tn-1. And if nobody arrived during that time, that's the result. If we do that iteratively, we don't find the right moment when we can add the passenger, I'll go to the previous interval. And do the same binary search first to the t target when the queue size will be equal to the capacity, and then do this t-target -1, and then iteratively, and then again, if not successful, you're gonna search in the previous array, previous interval. And the complexity of this one, in the worst case, is gonna be O of n time complexity, because there will be a situation when there are gonna be step array, step queue size function, and every moment of time it's gonna increase by 1, and we won't be able, it will be like 10 to the 5th moments of times, and we won't be able to, and the capacity will be somewhere in the middle, and we'll go down the slide until we go to the moment when the queue size will be like equal 0, if it's possible, and this one will be n of n. So the time complexity is O of n. Space complexity. So the space complexity, I will just sort the bus's arrival and passengers arrival, and gonna be in place sort. And yeah, and so it's like O of n plus O of log n for the search, plus sort is gonna be log n. And so the time complexity of this algorithm is like log n, because we need to sort it first. Okay. Sounds a little bit complicated to implement, I would say. So let me try to start coding that one. Code. So we have this latest in a bus. We have passengers capacity. So arrays sort buses. Then I get arrays sort. It's autocomplete. I didn't know that it allows autocomplete. Whatever. Array sort passengers, and then we need to have this private int binary search function, and then we're gonna start from there. So the passenger, that's issue that I'm currently thinking about. So how are we gonna map buses intervals to the passengers intervals? So if the they're definitely gonna be in indexes, yeah, and I need somehow to know the like these indexes of one another. It seems like it's not real. Okay, probably gonna wrap up. It's close to 1 hour, so I think it's failed. Like pass or fail, I guess it's failed. Yeah. See you soon.